Hello everyone. So in this video we are going to continue our discussion on clustering in learning algorithms. So first algorithm we are going to study is k-means algorithm. K means clustering algorithm. The k-means clustering algorithm is unsupervised machine learning algorithm. So there is no target variable, unsupervised machine learning algorithm. If you see the name k means it has two terms, k and means. The K stands for group the data points into K clusters. K is number of clusters. K is number of clusters we group the data. Number of clusters we group the data. And means, what is this mean? Mean stands for average of data points. Average position of data points in a cluster. I would say average position of data points in a cluster. So this is K means cluster. So in general, if I write what the K means does is, what is the goal of K means? What is the goal of K means? It is to group the similar data points in K clusters, K number of clusters with the center value known as centroid. The center value, that means centroid. If I write it, the goal of the K means is group data points into K number of clusters with a centroid. So what is a centroid here? Suppose we have these data points. These are the data points we have. And this forms one cluster. This is our cluster. And the centroid will be the center point from which the data points in the cluster are approximately equal distance. So this will be the centroid. Every cluster should have a centroid in k-means. Okay, so this is the basics of k-means. Now let's see how our algorithm works. Working of k-means algorithm. Step 1 is to choose number of clusters. That is k value. We have to identify the k value. How many clusters will be suitable for our data? For this, we will use elbow method and Silhouette scores. Okay, which I will cover in next video. But here in this video, we will focus on the working of k-means algorithm. So we will just randomly select the k value and understand how our k-means algorithm works. Our k value can be anything. K is equal to 2 or k equal to 3 or k equal to 4. If you, based on this k value, our model will build that number of algorithms. K is equal to 2, it will build 2 clusters. K is 3, it will build 3 clusters. If k is 4, it will build 4 clusters. It will form 4 groups of data points. So step 1 is to choose the number of clusters. And step 2 is initialize centroids. Initialize centroids. At this step, the first centroids, suppose consider k is equal to 2. That means I have two clusters. The algorithm has to form two clusters, two groups of data points. So it will randomly select centroids C2 and this is C1. It will randomly select centroid C1 and C2 if k is equal to 2. There is no mathematics, no logic, nothing. Initially it will randomly select the centroids. Okay, initially it will randomly select the centroids. Step 3, the algorithm step 3 is calculate Euclidean distance. Calculate Euclidean distance between every data point and every centroid. Every data point and every centroid. Suppose we have data points here. These are data points. And our algorithm has initialized k is equal to 2. We have selected k is equal to 2. That means we have to form two clusters. According to step 2, it will initialize two centroids. Consider this is randomly selected centroid C1 and this is some randomly selected centroid C2. Now the algorithm will calculate Euclidean distance between every data point and centroid. Every centroid. Not only centroid, every centroid. That means it will calculate Euclidean distance between C1 and this point, C1 at this point, C1 at this point, all the points it will calculate. Same it will do with the C2, centroid 2. It will calculate all the distance between every data point with centroid 2 and distance every data point and centroid 1. Next comes the step 4. After calculating the Euclidean distance, step 4 of the algorithm is assign points to centroids. Assign points to centroids. That is with the least distance. With the C1 it has calculated so many points and with C2 it has calculated distance with all the data points. It will find which centroid the data points are close and it will assign those data points to those centroids. If I draw and show you, consider a point A, B, C, D are close to centroid 1 and point X, Y, Z and R are close to centroid 2. Then it will form two clusters. Assign these points to these two centroids and form the cluster. Now it has assigned the points to the centroids. Okay, the centroids are randomly selected points. Step 5 is update the centroids. Update the centroids. See, in step 2 we have initialized centroids. We have randomly selected and found out the nearest data points to those centroids and formed a base clusters. These are basic clusters we formed from the Euclidean distance, but these are not perfect clusters. So what the k-means algorithm does is, now it will update the centroid. How it will update the centroid? I will show you with an example. Consider this is centroid 1. Okay, with the first let me write. So these are our points x and y. Okay, these are our features, and our first centroid is C1. Our initial centroid, it is randomly selected 15 comma 20. Value is 15 comma 20. The points which are in the centroid are A, which are nearest to the centroid are A, 20 comma 30, and point B, 30 comma 40, and point D, 40 comma 50, and it has formed a cluster. Okay, after step 4, it has formed a cluster like this. Considering example data, this is not the original data, just for an example. Okay, it has formed the cluster like this. So if you notice here, our centroid is not at the center of the cluster, right? This is, consider this as the center of the cluster, should be somewhere here. It is not at the center of the cluster, it is at the bottom of the cluster. Definitely this is not the centroid. We have to update the centroid. So step 5 is to update the centroids. And how it will update the centroids? It's very easy. It will just take the mean values. See, it will calculate the mean of these points, x points. And then it will calculate the mean of y points. That's all. These are x points, x, x and x points. These are y, y and y points. This is x point of centroid. This is y point of centroid. We will calculate the mean of data points which are close in this centroid, which are close to this centroid. So our new centroid points will be, for x it is 20 plus 30 plus 40. That is 20 plus 30 plus 40 divided by p. That is equal to 30. And y is 50 plus 40 plus 30 is plus 40 plus 50 divided by p, and it will be 40. So new centroid will be new centroid C1 is equal to 30 comma 40. That is this point. Now this data point will be our new centroid C1. So this is our new centroid. Okay, we have we have to update centroids using this logic. Same it will do for C2 now. Same steps it will do for C2, and find out the new centroid. And what is the next step? Next step is repeat until convergence. Repeat till convergence. Repeat until convergence. That is from step 2 to step 5. We have to repeat the process. What is the process? Step 2 is calculate distance. Sorry, not initialize the centroids. From step 3, from the step 3 to step 5, we have to repeat these steps. We have to calculate again. We have to calculate the distance. We got the new centroid now, C1. Same way we will get the new centroid C2. New centroid C1 and C2. These are new centroids. And we have to calculate distance from these centroids to every data points. And again we have to assign the values to form the clusters. Assign the values. Nearest values, assign the nearest data points to these centroids to form the cluster to form cluster. After forming cluster, again we have to update the weights, update the centroids, update the centroids. Again we have to find the new centroids, and again we have to repeat. So this will be repeated in a loop. This will repeat in a loop until convergence. What is until convergence stands here is when we have to stop, when we have to stop until convergence, until first point is centroids don't change, centroids do not change. If the new centroid value is same as the old centroid value, centroids are not changing. After updating the centroids, our centroid value is not changing. That means we have to stop. The algorithm will stop, and those are our final centroids and final clusters. Final centroids and final clusters. Or, or, or assigning points do not change. Assigning points do not change. That means we are updating the centroids. We are updating the centroids. We are calculating the distance, and again we are assigning the values. And those assigned values are same which we have assigned for previous centroid. And those values are same again for the new centroid also. There is no change. There is no addition of new data point to the cluster, or there is no removal of a data point from the cluster. There is no change in the assigning of the data points. Then you should stop. The k means will stop the process, and those will be our final clusters with centroids. We have found the clusters and centroids. This is how the k-means algorithm work. I have done a practical example to demonstrate you. Okay. Here what I have done is I have taken the customer segmentation data. We have the gender column, age of the customer, gender of the customer, the annual income of the customer, and spending score, which is between 1 to 100. If the spending score is more, that means customer spends a lot. If spending score is near to 1, that is customer doesn't spend a lot. Customer spending is less. So I want to make clusters on this data using k-means. This is for understanding, okay? For understanding purpose, I am using this data. We have 4 columns here: gender, age, annual income, and spending score. To visualize and better, and for visualization and better understanding, I will use only these 2 columns: annual income and spending score, to form the cluster and visualize the data. So what I have done is I have visualized this data. See, annual income is x-axis and the y-axis is spending score. Both are input features. If you observe this data, you see annual income is less, 20 to 40. Okay, and spending is also between 0 to 40. So low income, low spending. This can be one cluster. Can you see this? This can be one cluster. And low income, income is low, 20 to 40, but spending is high. This can be another cluster. We can form another cluster here. Low income, high spending. And the income is between 40 to 60. Spending is also between 40 to 60. This cluster, this group of data points. See, moderate income, moderate spending. Moderate income, moderate spending. Our third cluster. We can form one more cluster here. And if you see now, high income, low spending. These points. Income is between 80 to 140, but spending is less. It is less than 40. So high income and low spending. We can form another cluster. High income and high spending. This is this data points. We can group these data points into high income and high spending. This forms one more cluster. So in this data set, we can approximately form 5 clusters, which I can predicting from visualization. Okay, but this is not the way. We will use the elbow method. I will teach you that in the next video, but understand how the clustering forms. See these data points and understand how the cluster forms. So you have to do all the feature engineering, data cleaning, data pre-processing, feature engineering, feature scaling, and then do the machine learning algorithm. Then you have to build the machine learning algorithm. I have skipped those steps because my main focus is on demonstrate the k-means algorithm. I have selected only two features here, annual income and spending score as my features. I did the scaling and built the k-means. In the k-means, if you see here, see, I have specified k is equal to 5. K is equal to 5. Manually, I am specifying k is equal to 5. Okay. I have fit the model. K means dot fit. It is again in the Skittler library. We have k means algorithm. We can use from the Skittler. After fitting, if I visualize my clusters, you see here. Can we see 5 clusters? These into one group. Low income, low spending, yellow points in one group. Low income, high spending, green points. Moderate income and moderate spending, purple points, data points. These form one more cluster, third cluster. High income and low spending, that is light green. These green points, light green points. And high income and high spending, those are blue points. You see, I have grouped my data into 5 clusters using two features, annual income and spending score. This is how k-means will form clusters. Okay, so these are the 5 clusters I have formed using the k-means algorithm based on two features, annual income and spending score. Now let me visualize the centroids. I have also done the visualization of centroids here. See, these x points, the big x points you can see, these are centroids. If you observe this, these are at the center point of the cluster. You see, they're surrounded by all the yellow points. This point is surrounded by all the purple points. This is surrounded by all the blue points. So it is approximately at the center. You can visualize that it is approximately the center. So this is how the k-means algorithm will work. Will form k number of clusters and group the similar data points into those clusters with a centroid. This is the working of k-means. I hope you have a good understanding. In next video, we will cover the next concepts of the clustering. Thank you.